this video, we will be taking a look at the 1st of January higher plus 5 a day, okay, for GCSE 91 mathematics for all exam boards. This is the PDF, guys, and this video was recorded on Sunday the 12th of September 2021. Right, guys, before I start, if you're new to the channel, welcome. Thank you for clicking on this video. Please subscribe to the channel if you can, like this video, okay, and also press the bell icon so turn on post notifications so you guys don't miss out on my further and regular uploads for Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths and further maths, and also further education in mathematics for university degrees and masters. Okay, and comment below if you've got any topic requests, any questions or any queries about this video. Right, guys, question number 1. Okay, so it's the 1st of January actually, okay, and it's the higher plus. Okay, question 1 says prove 2n plus 2 all squared, subtract brackets 2n plus 1 is always odd for all positive values of n. Now, for an odd number, guys, we want our answer to be in the form 2n plus 1, okay, where n is what we call an integer, so a whole number. Okay, so when n is strictly bigger than 0, okay, so it's for all positive values of n. Okay, so we want our answer to be in this form, so 2n plus 1 or even 2n plus 3 or 2n plus 5. So what I'm going to do is I'm going to expand this bracket, collect all the like terms, and I'm going to try and make it look like in this form. So 2n plus 2 all squared actually, so I'm going to have 2n plus 2 times 2n plus 2, okay, and then I'm going to subtract 2n minus 1, okay, because when I have like a minus and a bracket, I've got like an invisible 1 there. Minus 1 times 2n is minus 2n, and then minus 1 times positive 1 is negative 1. So expanding this bracket, guys, 2n times 2n is 4n squared. 2n times 2 is positive 4n. 2n times 2 is positive 4n, okay, and then positive 2 times positive 2 is positive 4. So when I expand double brackets, every term is being multiplied by the corresponding terms in the other bracket, if that makes sense. So it's 2n times 2n, 2n times positive 2, 2n times positive 2, and then 2 times, okay, 2. So collecting like terms, guys, okay, so I'm going to have 4n squared, okay, I've got 4n plus 4n subtract 2n, so that's going to give me positive 6n, and then I've got minus 4 minus 1, which is minus 5. Okay, so I've got a quadratic expression that is left. Now what I can do is I can factor out a 2 out of these first two terms. So if I take out a 2, okay, I'm going to have 2n squared plus 3n subtract 5, okay. And if we stop here and just take a moment to think about it, so 2 times n plus 1, well, so 2 times n, okay, so this is essentially what I call n, okay, so I've got 2n minus 5, so that is definitely going to give me an odd number, because 2n is always even, okay, and then adding that 1 makes it odd. So this part here, so 2 lots of 2n squared plus 3n brackets, that's always going to be even. But when I subtract that 5, that is what is going to make it always odd. Okay, so it's in that form actually. Now, another point that she mentioned is I don't have to fully factorize this. Okay, so and what I mean is I don't have to take out 2n as a factor. What I've done is just take a 2 out because I want it in this form. Okay, so it's 2 times something plus an odd number, okay, or minus an odd number. Okay, so 2 times something, subtract 5. Remember that when you have a bracket, there is like an invisible time sign there. Okay, so that confirms that that is going to be true it's going to be true for all odd numbers, regardless of the value of n, okay? But for our case, it's when n is a positive integer, so when it's strictly bigger than 0, okay? So you can try numbers by putting in it, but it's always going to give you a odd number for that question. Question number 2, guys. Rationalize the denominator 3 plus root 2 over root 3. Now, rationalizing means getting rid of the surd on the denominator of my fraction. So I'm going to multiply this fraction by 1. Okay, now, this is like a special case, so I'm going to multiply it by 1. Okay, so multiplying it by 1 doesn't actually change my answer. But in this case, I'm going to write 1 as root 3 over root 3. Okay, so anything divided by itself is always 1. Okay, so I'm essentially multiplying this by 1, but I'm representing 1 in the form of root 3 over root 3. And it's going to become clear in a second why I've multiplied top and bottom by root 3. So on the top, I've got 3 times root 3, which is 3 root 3. And then root 2 times root 3, which is going to be root 6. Okay, all divided by root 3 times root 3, which is square root of 9, which is just 3. So my answer is now rationalized because there is no surd on the denominator of my fraction. Okay, so hopefully that makes sense. And the reason why I've multiplied by root 3 over root 3 is because if I multiply a surd by itself, then it's always going to give me that whole number. So what I mean is, if I have root x times root x, that's always going to give me x as my answer. Okay, so it's using that rule there, guys. Okay, question number 3, it says shown is f of x. Sketch the function f of x plus 1. Now this is what I call a translation vector in the x direction by -1. So that the f of x plus 1 means that all the points are shifted one place to the left. So it's going to now cross at -1, 1, and it's going to cross here at 3, 4. Okay, and it's obviously going to cross somewhere here on like the next part of my graph. So it's going to look something like that. Okay, so that is my answer for question number 3. Okay, so everything is shifted one place to the left. Okay, so f of x plus 1 just means a shift in the x direction to the left by 1, okay? If it was f of x minus 1, then it'd be 1 to the right, okay? So it's always the opposite to the sign inside the bracket. Right, guys, the last question here actually, which is looking at composite functions, and f of x equals 3x plus 2. G of x equals x squared. The first part is to work out what f g of x, so it's a function of a function. So it's going to be f of g of x, so f of x squared. So what I'm doing here is I'm going to replace x with x squared. So it's going to be 3x squared plus 2. Okay, or they will accept 2 plus 3x squared. So either way is going to be fine. Yep, so they will also accept 2 plus 3x squared. Okay. And the last question, guys, find GF of 5. Well, let's work out f of 5 first. Okay, so f of 5 means that I substitute 5 into here. So it's 3 times 5 plus 2. So it's 15 plus 2, which is 17. So I'm going to work out g of 17, which is going to be 17 all squared, because the function of g of x is squaring the number. So 17 squared, guys, is 289. So the answer for that question, GF of 5, is 289. Okay. And the answer for FG of x, just to be clear, so FG of x is 3x squared plus 2. Okay, so it's working out the function of g of x and then replacing that with x. Okay, so it's f of g of x, so it's f of x squared, which means replacing x with x squared into the function there. Okay, and that gives us our answer. Okay, and that, guys, is the end of the video. Okay, so this video is useful for those of you doing higher tier for AQA, EDEXCEL, OCR, WJEC, IGCSE, CIE, and all the other exam boards for higher tier. Okay, like I said at the start, if you found this video useful, please subscribe to the channel, like this video. Okay, check out my other videos on this channel. Okay, and also click that bell icon to turn on post notifications so you guys don't miss my regular uploads. Okay, that's it for today, guys. Thanks for watching. Stay safe, stay healthy, and I'll catch you in the next one. See you later, guys.